Hey guys, how's everything going? This is JSer. So this is the last contest I'll attend before my interview, the day after tomorrow. Hopefully, I can do it well. Um, well, from a previous experience, I think the weakness of myself is that the penalty time. So I need to review carefully before I submit the my code. Hope I can do better this time. So 6, 5, 4, 3, 2, 1. Let's go! Okay, the first one. Maximum product of two elements in an array. Are they? I think we have done this before. Anyway, we're given the array of integers. I will choose two different indices, ij, return the maximum value of nums I minus 1 times nums j. So like 3, 4, we choose indices of the previous one, right? So, so the previous one. Maximum value, that is 12. Wait a minute, maximum value of minus 1. So 4 minus 1 and 5 minus 1. So we could just loop through all of it to find the product of all the possible pairs. So that's n to the power of 2, and but we could do better. The product of two elements actually are should be the product of here divided by here, right? So we can catch it with linear time and get the max. So okay, let's do that. So this minus 1, does it change everything? I think no. This still the maximum. Yeah. Okay, so let's create a result. Let's create a product 2. Use this array to cache the result. New array. So it should have array nums.length, right? Fill 0. We'll fill them up, so it doesn't matter. For let we need to get the index, so let's I equals 0. We will push the product of all the elements till this index to this product 2. So let the product equals 1. So product, we times it with nums I minus 1. We times it and set it to product. Wait a minute. Two different indices. No. I made a mistake. These two elements, not the two subarrays. So yeah, sorry, I made a mistake. Okay, let's just first try to use a brute force to see if we could let the max equals minus infinity. Oh, I'm sorry. I'm so sorry. Let input. Wow, there's a lot. It's the product. The product should be two largest nums, right? The nums will be positive. So I think we're just going to find the biggest numbers, right? We don't need to do the calculation. We need to, okay. You need to find the the largest two numbers because the numbers are positive. Cool. So let's create an array called top2. It should be infinity and minus infinity. Okay, for the num of nums. We updated this top2. So the first one is largest one. Okay, if num is bigger than top2 0, if it is bigger than the 0, of course we need to update it to top2 1 equals top2 0, right? And set top2 0 to num. Else if num else if it's bigger than this one, we update it. If it equal to it, we still update it. Okay, so equal should be counted. And if it's smaller than it, but it's bigger than this one, so if it's bigger than top2 is 1, we set top2 1 to num. Right? And if it's smaller than it, we don't do anything. So finally, we should return the top2 to 0 minus 1 times top2 1 minus 1. Okay, let's try to run our code. Result, use sample test cases. 12, 16, 12. I think it should work. Let's try to see if we need irregular cases. It's okay. Top2. Okay, so the top 2, yeah. They're all valid. It must be at least 2. And then nums is positive. So I'm sure this should be right. Cool. Yay. No penalty time. Great. Though we have, we use 6 minutes. Not bad. Comparing to the other guy. I'm slow, but no penalty time. Okay, next one. Maximum area of a piece of cake after horizontal and vertical cuts. Given a rectangular cake with edge and width, and 2 arrays integer horizontal cuts and vertical cuts in the distance from the top of the rectangle cake. Okay. Return the maximum area of a piece of cake after you cut at each horizontal and vertical position provided by it. For case our legs cut here, and we can get the maximum area. If say like this, area will be the same. So the area will be 6. So let's see what is the piece of cake. So there must be 2 adjacent cuts, right? And adjacent cuts. The answer can be a huge number. Return this module. The input. Let's see. There is a lot of cuts. And the horizontal cuts. Okay. Vertical cuts. Vertical cuts. It is guaranteed all distinct. Guaranteed. So actually, for each cut, the maximum will be happen at. You see, if there. So suppose we only take a look at the vertical cuts. So all the arrangement of the horizontal cuts are the same for each vertical cut. So the vertical maximum here would be this row, right? This column will generate the best cut. And if we just take it horizontally, this will be taking the biggest cut. So actually, we're going to get the maximum here, right? Maximum here times maximum vertically, the space. So that will be the biggest cuts. Well, things become simple. const. Okay, let max distance h equals infinity. Let max distance vertical equals let max infinity. All the cuts are valid. So let h of horizontal cuts. Horizontal cuts is this is horizontal cuts, one horizontal cut. This is horizontal cut. Okay, so the prev. Okay, so we could use a prev. Prev is 0, 1, and go to How can I do this elegantly? Okay, I think with H W. I think I put the horizontal cuts at the last one, which is 5. So it just should be okay. 5 equals 1, 2, 3, 4, 5. Okay, it's based on 1. Man, the cuts 3, 1 is based on 1. So we need to keep track of the last one, which is H, and let prev equals 0, right? And then we will update the maximum distance H. So we say max distance H equals max itself plus H subtracted with prev, and update prev equals H, right? Okay, previous one is 0, we got 1, so the distance is 1, set prev to 1 and got 3. Finally, we got 5, so we can get okay. And we will do the same for W. Prev equals 0. Let W of vertical cuts update it. This should be W, that's prev equals W. So we get the maximum vertical cuts, and then we could return, we just return the this times this. This should be right. Let's use example test case. We got 449, 4, 6, 9. Why we got 4? 6. Ah, we forgot to push. Man, we forgot to push the vertical cuts. 4, 12. 12? What? Wait a minute. Vertical cuts? Vertical cuts, right? Max div. 4? This is 4. Why we got 12? This is horizontal cuts. This is vertical cuts. Allow me to log the max distance speed. So for here we got 2, 2 is right, and here we got 4, 3. 4? Where did we get 4, man? We get 1, 2, 3. Ah, I see what happens. They are not sorted. Man, we're not sorted, so of course we need to sort them first. Man. Oh man, sort. I'm not sure whether I'm doing this right, but sort seems to be a good approach. Let's sort. This should be okay now. Use example test cases. We sorted. We got 4, 6, 9. Looks good. I'm confident for this one. Submit. Oh my god. What the fuck is this? There will be no overflow for this one. I've already sorted them. Vertical cuts. And we get the max distance. W. This is the H and W. This is the horizontal. Wow, this is a lot big. I need to return the module? I forgot this one. Shit. Oh, the browser froze. Let's see if this is equals to the module, which is this one. Okay, this module plus 7. Oh, what happened? 955. Yeah, I forgot to module them. Okay, sad. Oh, my browser got a problem. Okay, return it. Module by plus 7. This is plus 7, right? Plus 7. Okay. Let's submit. Cool. Accepted. Nice. Penalty time. Shit. I hate penalty time, man. Next one. Reorder routes to make all paths lead to the city 0. There are n cities, numbered 0 to n-1, and n-1 roads, such that there is only one way to travel between 2 different cities. Only one way. Last year, the ministry. Okay, so there's only one way between 2 different cities. Network. Last year, the Ministry of Transport decided to orient these roads in one direction. Orient the roads in one direction because they are too narrow. Orient, I don't know what they mean. Roads represented by connections, represented by road from A to B. This year, there will be a big event in the capital, and the people want to travel to the city, to the origin, okay? My task is to consist of reorient some roads such that any city can visit city 0. Return the minimum number of edges changing. For a graph like this, change the direction of edges shown in red, such that each road can reach. We need to reverse it. Change to the node. Go to the node. Oh, so 3. For this one, reverse it. So then this one, could, and go to 3. That's 2. Oh yeah. So it's for example 1 to 0, 2 to 0. So how would we solve this problem? Because the original path are all. Well, I can think we can just do the traversal, like we traverse through the tree. So, but we could do it DFS or BFS. It's okay. There's only one way to travel between two cities. If there's a tree, if there's an edge between 3 and 4, what happened? We don't need to turn in here, right? Actually, 1. We could just change. There's no new one, but change the direction. So if there's a edge from 4 to 3, we only need to change 3 to 4, right? We only change it to 4. That means the shortest path to 0. If we change this, oh, how should I approach to this problem? Minimum number of edges. The input, there will be a lot of cities, connections equals to n minus 1. Connections equals n minus 1. So there will be actually n. There's only one way to travel between two cities. So there's no tree like 3, 4. If there's 3, 4, there's no 4, 0. Something like this, right? If that's the case, I think we should do it. These are all different trees, a different subtree. So if we change, so we have to do DFS and reverse them. If 1 or 1, so we will now reverse 3. If there's 3 to 2, and then we skip and go to 2, and just to do it, right? If there is a, so from the input we see the connection's length is n minus 1. There will be no extra. It's a tree. There's no like circle thing. So yeah, we just count them. So DFS and count. Cool. Okay, so let's do it. So the just to count the how many roads are in a invalid direction. First, we need to generate the map, right? Create a forward map. Okay. New map. 2 of connections. If we get has from and get from okay, you set add to if not set from new set 2. Okay, now so we have a tree actually we get from 0. So we'll use DFS. Let count equals 0. So how can we determine if there's a if we go from 1 to 3, then we need to turn it to 3 to 1. If not, if there isn't, oh, we cannot traverse through this. Connection means to 2 to 3. And then there's another one like 2 to 4, right? So there's some isolated subtree. So we will, okay, we try to get to 3 and then mark them as all traversed and then go to the next one, right? The n will be very big, but we could just look through the forward map. When the start is isolated, it means this actually could be this is connected to some for some tree. Okay, I see what happened. Let's create a mark. First, traversed. Set. Okay, we will start from this tree here marked. So we will actually the map has 3 heads. It's 0 to 4, but we will traverse through actually 0 and traverse through 1. Calm down. And the forward map will be 0 to 1 and 1 to 3, 2 to 3, and 4 to 0, 4 to 5, right? Because there's no element to 4. Okay, from 0, we should start from 0. If not, maybe we can encounter something like 3. And we go to 4. But 3 is not. Yeah, we should start from 0. This is 3, 4, 5. From our assumption, this 3 should be valid. Okay, this doesn't matter actually. And 3, 4. We need to change it to 4, 3 because this should be the head. Okay, cool. So we set a new set of traversed. We could still start from any node. So for let from a forward map. Oh no, if if we encounter 5, and we don't know whether this 5 is right. Actually, we should start from 0. We start from 0 and go straight down to 3 and stop them, mark them as and count them and go back, and then we can start from another one. Okay, I'll create first collect the cities reachable from 0. So I'll create a collect method, which is the node start from 0. What it will do, actually, will do DFS. So we create a stack and put the node in. And then while stack is not empty, we pop it, right? Top equals stack pop. Pop it, and the top, if it is traversed, it means that it could reach the 0, 0 city. So we skip. Yeah, so if traversed, traversed, set. If traversed has top, then we continue. We do nothing. And if it's not traversed, we need to push the elements in, right? So for it may 2. So it might have no next city. So for if top forward map has top, next of forward map get top for each of them. If the for 4, for 3, next one is no, right? No one. So we do nothing, but it will go to 2. But for 2, we just you go to 3. It's okay. It's okay. So we go to these children. They should move backward. Yes, that's right. But for 4, right? But for 4 is okay. The next one is 0. So if it's 0, we do nothing. And we only check some points that is not 0. Okay, so if next is not 0 and it is not traversed yet, if it is traversed, then it should be reachable. 0, for 0, it's already traversed, so we could just say if traversed has next, it's not reachable. Okay, we can maybe rename this reachable. Okay. If it's reachable, no, traverse is better. If it's traversed, we push them in, right? We push them into the stack. We push them back to next. So this is the collect method, and if it is traversed, we continue and push the children, and this will be wait a minute. We go 2, 3, and we push the children in. And again, we only push the things that is not traversed. So that means each node will have a backward if we process them. So we need to count them up, right? We count it. And now, so we will do what? We collect from 0. And then we for each format for let from a format, we will collect them. But this actually should be start from 0. No, it might not be. You see. So finally, we will return the result. Let's try to see if we get it right. Runtime error. Result is undefined. Result? Oh, count. Yeah. 15. What? 15? What do we get? 15.75. 15.75? What? Okay, let's log the format. It's so sad. Let's get the format. Okay, we got 0 to 1. 1 to 3. 2 to 3. And 4 to 0, 4 to 5. Okay, so we now look through them and collect, right? Connect. We collect. And we collect from 0 first. And we put 0 in. For 0, we got 1 only. So traversed. Look at that. And then, okay, we pop it. So this 1, 0. Ah, shit. We should put the 0 in it, actually. We should set 0 in it. The origin is already traversed. Got it. And then we continue, right? But we already... Oh, not continue, man. It should not be continued. We should just use empty. But if it's 0, we should not count. So if it's origin, if top is 0, if not is 0. Collect from node. If it's not node, we count it, right? It's if it's from the child, from the child, from 1, then there's a root. Or say we should not count here, but add it up when we have a when we push, right? So here should +1. This is better. We get 10 for 2. 10? What the? If Travis has it, no. Continue, no. Is it because I forgot to put it into add top? Forgot. I think this is the mistake. 320. 320. Looks great, but I am not confident in this one. Have some faith. Is there any null node? Connections might be okay. Connections might be 0. Cities will be at least 2. Connections. Oh, there must be a connection. So let's see some special cases. If it is if it's like 0, 1, it's no, which is 0, right? Cool, good. Man, accepted. Yeah, no penalty time. Cool. Okay, next one. Well, seems good. Seems pretty well. Last one. Probability of 2 boxes having the same number of distinct balls. Wow, such a long description. Given that 2n balls of k distinct colors, okay, I will be given an integer array balls of size k. Where balls I is the number of balls of colors I. So the colors, right? So it means for each color, how many balls are there? All the balls will be shuffled uniformly at random. Then we will distribute the first n balls to the first box. First n balls to the first box, and the remaining n balls to the other box. Please read the explanation of the second example carefully. Wow. Please note that the 2 boxes are considered different. For example, if we have 2 balls of colors A and B, 2 boxes, and then the distribute AB is considered different than BA. We want to calculate the probability that 2 boxes have the same number of distinct balls. What do you mean? So we have balls 2n. So for the color size, for color 0, it will be 1 ball. This one is 1. Yeah, this is the 1 color A and 1 color B. So we distribute this into cut them into half. So 1, 1, and 1, 1 are different. We want to calculate the probability that 2 boxes have the same number of have the same number of distinct balls above color 1 to box 1, color 2. So in both ways, the number of distinct colors in each box equal probability of 2 is 1. Well, I still don't understand what the problem is. The second one, 2 explanation. We have the set balls 1, 1, 2, 3. Yeah. The set of balls will be shuffled randomly. We may have one of the 12 distinct shuffles with equal probability. 1, 1 of 2. What does it mean? We have 2 colors of 1, okay? And if we shuffle, this is separate, right? Yeah. I have 1, 1, 1, 1, 2, 3, 3, 2, 1, 2, 1, 2. 1, 1, 2, 3. 1, 1, 3, 2. Yeah. 1, 2, 1, 3. 1, 2, 1, 3, 1, 3. 2, 1. 2, 1. 2, 3. Something like this. This is the first box, right? This is the second box. The second box could also be 1, 1. Yeah, it means here. And 1. After that, we add the first 2 balls to the first box and the second balls to the second box. we can see that 8 of these possibility random distribution have the same number of distinct colors of balls in each box. Distinct is 8. Okay, this one, right? 1 and 2 and 3, 4, 5, 6, 7, 8, 9. Oh, this is not. This is 8. So probability is this. What? Okay, this is like this. 1, 2, 1, 2. So 1, 2, 2, 3, 4, 4. It's hard to display all the possible random shuffle, but easy to check them have the same get probability. For like this will be all the same, right? So y output is 9. Numbers of distinct colors. We shuffle, and all of them should be 6. So they must be exactly the same. Colors will be 0. What? Why 0? Divide them equally. I made a mistake. It's not. It means 6, 1. Oh, I see. So, if we we have 2 n balls of distinct colors k. The probability will be like have n, right? Are the same distinct color. We suppose there are 2 boxes, and then we throw a ball from next ball into this box. It will have the chance that they fall into each box. So for each ball, actually there will be 1 out of 2 chance that to be on each box. So suppose this is the balls. The problem asks us to actually pick 3 of them, any of them, randomly. Pick any of them and count. And it's not that big. We need to count what? We need to count if they have the same distinct color, right? We don't know each. Okay. Well, I think we just do brute force and do the check. Yeah, just do brute force. We will look through all the possibilities of the box, because only 2 boxes, and the ones in it, the ones picked in the first box, will be okay, will be, say, we create a counter way to track of that. So count equals count 1, right? This is box 1 will be array, because you see we start from 1. Okay, we count 1 to the balls will be defined as the colors. So the colors is like this. This is 4 colors, and start based on 1. Okay, so new array balls .int +1, right? And the field is 0. Const 2 equals count. Okay. New array balls int +1 field 0. The rest will be count. We will first count the balls into count, and then pick balls to the first box. The rest will be the count. The rest will be in box 2, right? So for let I of balls. No, we need to get the index also. So see. So count I +1 actually should be balls I, right? Now we get the count. You see the should actually be the same. Anyway, was based on 1 to make it just closer enough to the exam. And now what do we do? Well, we will try to pick a ball. Try to pick a ball into the box 1. Right? Pick a ball. So we need to know the total balls. The count. Wow, this is hard. For example, we have 3, 1, 1, 1, 1, and 2, 2, 3. We pick one, so the count will be reduce 1, and this one will be +1. And we remove it, right? So, and we need to get the index also. So we need to so how can we get these 2? The ball is actually we align the balls. The balls actually will be 8 colors, and for each balls we're maximum 6. So actually there will be maximum 48 balls. We need to set up the colors. So const color of 5 balls, new array. We start with color. We just fill just do array. We update it. So color of balls. First one 0 should be 0's ball. Of course, it should be 0. We won't handle them. And here, for each of the color, this is color, right? So we count the color the balls. But let index j is from 1. But we will set for okay, while j, suppose there is 2 balls, should be 1 and 2, right? So while j is smaller than 1 part I, this is I plus 1 actually. So the first color, which is 1, so we start with 1 with the balls count, so plus balls I. Yeah, this is right. J plus equals 1. So we set the color of balls. We set colors of balls. This J equals to what? Equals to actually I plus 1. Wow, let's see if this is right. Oh, I'm so not confident. Count 1 color of balls. What do we get? We get like this is color balls should be count, okay, 2 1s 2 1s, okay, and 1 3 4. There's something wrong. 0 balls. How do we get the ball? Count is alright, right? The input is 2 1 1, 3 balls. So no, 4 balls. 1 3. The 4 is missing. Okay, I made a mistake. The first ball should be 1, second ball should be 1, the third ball is 1, 3. Where's 2? We loop through the balls, which is based on 0. And this is for the ith ball. The count is ball's I. So j starts from 1. This is root index, so the root index should be 1. Start from 1, so 1, 2, 1, plus 2, so it should be 1, 2, right? J will stop at 3. And next one, J is I. This one 3, and J. Oh, I think I know what happened. This is wrong actually. There's no relationship with 1 I. We just push the ball. So while J is smaller than okay, so let k equals to j, k smaller than j plus balls I. So which means j, and if there's 1 ball, yeah, this is right. K plus cut this ball. K equals I plus 1. This should be right. Oh, K. Sorry. Should be K. We set K to 1. And then J should be the J should be K. Let K start from J. K is smaller than J plus balls and K plus plus. We set K. And then K plus 1. What the? What an error. J is not defined. J is here. It's defined. J equals to K. Oh, K is not defined. Oh, yeah. Wow, this is hard. Okay, we got something. K start from J. We got Z. Empty. What? K equals to J. We update 1. K go to 2. Plus 2. So J plus 2. K equals 3. K set it to 1. And then K will go to next one. 2. 2 is smaller than K. No, K. 2. Yeah, 2 is smaller than 1 plus 2, 3. Okay, update it. So now we set K to 3. 0, 1, 2, 3. One empty item. What? Oh shit. she actually will stop at j plus bullseye. For j1, it will stop at 3. For this one, so 0, 1, 2, 3. This is j. Why we don't set console ball? God, we'll do this one. Unexpected JSer. What the? Oh, I couldn't even get this straight. Sad. J. Get the count. And for each, we get log the k, okay? K equals 1 and then k equals to 3. Why? Ah! I am so stupid. We use for loop, so there's nothing. We don't need to add it by ourselves. Okay, so for now, 0, 1, 1, 2, 3. This seems right? So 1, 2, 2, 3, 4, 4. Yeah, this is right. So now we have this color of balls. We'll start picking. Okay, so the count will be pick 2, right? What's up? It's huge. Anyway, let's try to do it. Count of all possible combination. Count of valid combination. We create a method called try pick, which is the index, which is the ball index. Okay, ball index. The idea is we will set the color of the balls, right? We pick it and update the count for count and count 1. And until we match the last one, we will check if they are their value or not. And then yeah, that's all. So end to do, end condition. Now we will do what? We will first we pick it. When we pick it, the idea is we will count for ball index. Okay, the color. Const color equals color of balls, a ball index, right? Yeah. So the count of color will be subtracted by 1, and count 1 color is actually, well, plus equals 1, right? This is why we pick. This is how we pick a ball from it. And then we will loop through the next, right? So while for if there is ball. Okay, so we could check here. Check ending condition is here. Now, if the ball index is actually equals to the color of balls dot length minus 1. If this is the last ball, we will check if if check is valid, right? Rather than we compare. Okay, I'll create another method called const pick 1. This is okay. Let count distinct. Okay, let's just create a check is valid. Is valid. Okay, const count distinct. Let count distinct 1 0. So we loop through all of them, which is the balls, the colors. Okay, the balls. This is based on colors. So we start from 1. Color 1. Okay, for let I equals 1, I smaller than count distinct. Means if okay, we can just use filter, right? This is color, so this is color false filter. Oh no, count filter zero, not 0. Next, okay. Count of combi. Count of distinct to 1. Use 1. We return if they are the same. Right? Okay, so if is valid. Okay, we just add this. If this is valid. Oh, the count of all combi should always +1, and the count of all valid should be +1 if it is valid, right? Yeah. For if that's not last one, we need to try pick the next one, right? So try pick ball index. For each, we need to try pick each. Try each ball. So for let I equals 0, the ball, if it is a ball is picked, we should not picked again. So actually, we should start from 1. Okay. We should set to let picked let picked in box 1 new set. Wow, this is a totally nasty implementation. We need to add to pick 1. We need to add it to add the ball index. Now, so for I1 to I smaller than colorless balls, right? And then I ++1. If it is not picked, this is definitely gonna be TLE, I think. If it doesn't happen, we try to pick it. Right? We try to pick it. Like try pick. I. This is I. So the ending condition is not actually a bar index, but the picked one box is equal to half of the nen, which is cut above divided by 1. But we actually start from 1, so -1 divided by 2. So picked one box size. If there's half of them, we will check the combination, right? For the other case, if it's not half of the size, we continue pick, but pick the rest. Pick one. Okay. So after this is done, we need to revert it, right? So we revert it like okay, remove, delete box, and the count color. We put it back. +1, count 1 color, divide by 1. So, and then finally, we log. I want to log the count of all combinations. Oh, what happens? And count of distinct. Oh, count of all valid combination. Well, go. 0, 0. What? Oh, we forgot to pick. Yeah. When we start pick, we also will start from here. So for I, we'll run this. Start. Oh, seems like time limit exceeded. We got 2 to 12, 120 to 12. It's 180. We got 120. Okay, the first one is 2, 12, 180. We got 120, so it's not right. What happened? Let's just take a look at this one. $120, 20. We pick one. Okay, the next one we will pick the next one. We try pick one. Find that if particular size equals to half of them, we plus 1 is valid. Oh, this one, right? We got 120. It's actually 180. Why? Okay, we say what's the problem? We only have 6. We only have 6 balls, right? Cancel log count of color of balls. We run it. We have 6 balls, right? And then we start from 1. We pick one. We pick one, put it into the box. If we have, and then we will start again. And we'll try pick again. If it doesn't have it. So pick index. Okay. Put that. Pick 1, 1, 2, 3. Put 3 back. Pick 4, 5, 6. Put back 6. Okay, pick, so there was 6 balls. 1, 2, 3. Put back 3. Now pick 4. Put back 5. Put back 6. Put back and put back 2 and pick 3 and pick 2 and put back 2, 4. Put back, pick 5. Put back 5. Pick 6. Put back 6 and put back 3. Pick 4 and pick 2. So this should be right? Let's see. So console log, actually we log the got one, which is picked 1 in box 1. Let's see what happens. We're going to put back 20 log. 1, 2, 3, 1, 2, 4, 3, 6, 1. Seems to be no problem. Right, just no problem. And finally we got all compy plus 1 is valid. So log we not log 1, we log the count 1. So 0, 0, 1, 2, so 1, 2, 0, 0. Because we choose 1, 2, 3. Yeah, so they are the same. Is valid. All true? It's obviously this is not true, man. Filter count 1. Then yeah, this is valid. I say should not be true. They're what I return, they are not the same. Ugh, God, it's this one. Yeah, if I shit. Okay, if I were just if I return the valid divided by count of all combination, what will happen? got 0.6, which is this one. Oh, I think we're getting the right answer. Really? TLE, right? Obviously TLE. Anyway, we return 0.3. Huh. Oh yeah, this actually, we get the right answer, man. You see? 0. It's totally the same, except the last one, we got TLE. So, it's TLE. Okay, this is the best I can do. I will implement the naive solution, but backtracking. But I'm not that good at the I'm not good at maths. This is the best I can do. I'll stop here. Hope it helps. Guys, I think my solution actually works. It's just a TLE, so I cannot do anything more. Yeah, let's see how many people tried and accepted. Wow, they are good at it. Okay. That's all for this one. Hope it helps. TLE. Shit. See you next time. Bye bye.